Okay, today we're going to look at performing operations with radicals. So to start off, we're going to add and subtract radicals. So remember that radicals are like your square roots. So we are going to use some of those skills we've had before, right, of like simplifying square roots, etc. So it says here you must have like terms. Like terms mean that it's the same, maybe I'll say like the root has the same index. So index is like your square root or your cube root, etc. And the other part we call the number inside the root is called the radicand. So here, when we're wanting to add together these radicals, so we've got the square root of 10 plus 7 square roots of 10. The fact that this is a square root, and so is this, and they both have the 10 on the inside, mean that they're like terms. In which case, you think about it, well, I have like, this is 1 square root of 10, and I'm adding 7 more, so this is equivalent to 8 square roots of 10. So think about like the square root of 10 as being like your variable. It's not going to change size, right? But you can combine the coefficients up front. Okay, this next one, you've got 2 cube roots of 16 and then 10 cube roots of 2. So while they're both cube roots, they have the same index, they don't have the same radicand, the number inside. But if I go ahead and I simplify this, so think about 16, right? 16 breaks down to 4 and 4, and then 2 and 2. And we're looking for a group of 3, right? Because it's a cube root, so we can pull 1, 3 out, and we've got a 2 left over. So the cube root of 16 is equal to 2 cube roots of 2. So you have 2, and then we have 2 cube roots of 2. And we're going to multiply those numbers up front, plus 10 cube roots of 2. Let's simplify that one more time. So 2 times 2 is 4 cube roots of 2, plus 10 cube roots of 2. Now we have the cube root of 2, and we've got a cube root of 2, so they are like terms, so we just simply add the numbers up front. 4 plus 10 is 14 cube roots of 2. Okay, same thing on this next one. We got to start by simplifying it. So you got to say, okay, well, 48, maybe that breaks down to 6 and 8, which is 2 and 3. And then we get 4 and 2, so we got a set of 2s, but then 4 also breaks down to 2 and 2. So we got 2 sets of 2. So that means 2 times 2 or 4 comes out front, and you're left with the square root of 3 on the inside. Minus, so 4 square roots of 3 minus 5 square roots of 3. We've got the square root of 3 and the square root of 3, so they are like terms, so we're just doing 4 minus 5, so that's negative 1 square roots of 3. Or you can just call it negative square root of 3 if you prefer. Okay, one more. Okay, so negative 2 square root of 6, that one does not simplify at all. 24 breaks down to 4 and 6, so then you get 2 and 2, and then 2 and 3. You get your sets of 2 and then 6 left on the inside. So you'd have 3 times 2 square roots of 6. Then we've got 8. Minus 2 times 8 breaks down to 4 and 2, which then breaks down to 2 and 2. So we get 2 square roots of 2. So we get negative 2 square roots of 6 plus 6 square roots of 6 minus 4 square roots of 2. So notice here, they're not all like terms. The square root of 6's are like terms, but the square root of 2 is not, so we can't combine those ones. So we can do negative 2 square roots of 6 plus 6 square roots of 6. So negative 2 plus 6 is 4 square roots of 6. But the minus 4 square roots of 2 would just be left as is. Okay, now let's look at multiplying radicals. So when we multiply radicals, you simply, as long as they have the same index, so the number on the outside, so that m, that's called the index, then you multiply the number in the inside, the radicands, by each other. So here we're simply going to do the square root of 5 times 18. You've got a couple different options here. We do want you to simplify this, so you could leave it as is and be like, well, if I'm doing 5 times 18, 5 doesn't break apart, but 18 breaks down to 6 and 3, and then 3 and 2. And then you notice the 3 are the ones that pair up, so we could pull out a 3, and then we're left with the square root of 5 times 2 is 10. You're welcome just to do it like that. I think that's probably actually easier. Or you could multiply it out and say this is the same as the square root of 60, and then simplify it from, oh sorry, wrong number, 90, and then simplify it from there. Either way works. Okay, this next one is a little trickier because there's numbers out front as well. Just like we multiply the numbers inside the radical, we're going to multiply the numbers outside as well. So 3 times 2 is 6. And then we have the cube root of 6 times 9. So once again, you can multiply 6 times 9 is 72, or you could just say, well, I'm going to break it down anyway to simplify the cube root, so you could just start here at 6 times 9. So that's 2 times 3. 9 is 3 times 3. We've got a group of 3's. We've got a leftover 2. So we'd have out front, we still have the 6 times, we pull out a 3, and we get the cube root of 2. So that ends up being 18 cube roots of 2. Okay. Next, this is something squared. Remember, anytime you have something squared, I always think it's easier to think about it as multiplying it times itself. I think you make the least amount of mistakes there. So 2 times 2 is 4 out front, and then we'd have the square root of 9. Probably recognize the square root of 9 as just 3, so that's 4 times 3, so we can answer 12. Okay, next we're going to rationalize the denominator. The idea behind rationalizing the denominators, or you can think about it as dividing radicals, is we want to get rid of the square root, or the root of the root in the denominator, meaning the bottom of the fraction. And we do that by multiplying both the top and the bottom. So I multiply by the same denominator, by the denominator, so like the square root of 3. But if I multiply by the square root of 3 over 3, that's multiplying it by 1, and I haven't changed the value of that. So now on the top, we have 4 square roots of 3. On the bottom, the square root of 3 times the square root of 3. You can think about that as a square root of 3 squared, which the square root and squared cancel. Or you could say that's a square root of 9, right, like we did above. And then so that just equals 4 square roots of 3 over 3. So notice that pattern kind of keeps consistent. At the bottom, the square root should disappear. So here we've got a square root of 5 on the bottom, so we're going to multiply both the top and bottom by the square root of 5. So on the top we get 6 square roots of 5, and on the bottom we just get 5. Feel free to pause the video and try these two on your own. So we're going to multiply by the square root of 11 over the square root of 11, so we get the square root of 11 over just 11. Last but not least here, we got the square root of 6 over the square root of 6. So we get 18 square roots of 6 all over 6. This one can be simplified one step further because 18 divided by 6 is 3 square roots of 6. As you learn a little bit more about trigonometry, you'll be expected to do this a bit more, so that's why it's a skill we're practicing. It doesn't feel like your traditional sense of dividing. Last but not least, I thought it'd be good for us to review what we learned about key features right before break. So here is some different things. So first we want to talk about the x-intercept. So where it crosses the x-axis, I want you to write it as a point. So we got 2 points. We got -2, 0, and we also have +2, 0. The y-intercept is where it crosses the y-axis, which is up here at 4. So that's 0, 4. Okay. Next, we're looking at domains. We want to say how far left The furthest point to the left is here at -2. Since it's a closed circle, we have to close the bracket. The furthest point to the right is over here at +3 for your x value. Open circle, so we get a parenthesis. Range, we're going low to high. It helps, this was like left to right. So once again, this point at the bottom, the lowest is -5. It's an open circle, so we get a parenthesis. The highest point is up here at 4. This one says it goes through that point. We usually use the bracket to mean it includes it. Okay, next we got increasing. This part of the graph right here is the part that's increasing. It's going up. Your y values are getting bigger. And we're going to write the x values there. So the x value of this first one is -2, and the x value of this other point is at 0. Okay, decreasing is where the graph is going downhill from left to right, right? The y values are getting smaller. It should start at that same x value at 0, but it ends at the x value of 3. Okay, an extrema is a maximum or minimum point. So in this case, we definitely have a max, right, at 0,4. As long as you can recognize that one, I'd probably say that's good. It's like your turning point. If you wanted to, like a little like bonus would be there is a low point as well. And there's a min at 3, -5 as well. Okay, we got another graph to do it with. X-intercepts. It crosses the x-axis at 2, 0 and at 4. So 4, 0. The y-intercept, it looks like, is right there at 4 as well, but that's 0, 4. Okay, domain is left to right. You gotta be a little careful here because, right, it has these arrows. So your graph is going up and to the left, up and to the left, up and to the left. It will go all the way to the left, so that's -infinity. And it goes up and to the right on this side, right? Up and to the right, up and to the right. So it goes all the way to the right. It's +infinity. Range is limited, though, because the lowest it goes is -2. It touches that point, so we're going to use a bracket. And it keeps going up, so that's +infinity. Okay, increasing, so we want the part that's going up. In that case, it's this right side of the graph. So that's from your x value of 3, and then all the way to the right, so infinity. The decreasing portion of your graph is this left side. You'll be a little careful because you may be tempted to write 3 to infinity again, but remember, as it's going 3 into the left side of this graph is -infinity. So we say it's -infinity to 3 as we write those x values. This graph has a minimum, and it is at the point 3, -2. All right, you should be all set to do your 4.4 homework now. Good luck.